Happy Wednesday, everybody. In this video, we're going to be going over 4.2, so the second part of Unit 4, solving inequalities using addition or subtraction. And you're going to see that this is going to be very similar to solving equations. Some of this stuff that I'm going to be talking about is going to seem like I'm just repeating myself from last semester because you're going to be used to it already. So the topic/objective for your notes is going to be solving inequalities and then the essential question for today is, how are the steps to solving inequalities different or similar to solving equations? So how are the steps to solving inequalities different or similar to solving equations? So that's the essential question for your notes. And so let's go ahead and get started. So before we begin this, we got to review a little bit of vocabulary, and that is by asking ourselves, how is an inequality different from an equation? Okay, so how is an inequality different from an equation? So we talked about the main difference between an inequality and an equation is the symbol that is in between them. An equation will always have an equal sign, while an inequality will never have an equal sign. It can have a less than, greater than or equal to, or less than or equal to sign. It's one of these four symbols that we've been working with for the last week. But it'll never have an equal sign, just the equal sign, because that would represent an equation. Now, the steps for solving these inequalities, though, and solving the equations, solving for that variable in there, is actually the same thing due to what's called the addition property of inequality. So the addition property of inequality states that when you add the same number to each side of an inequality, the inequality remains true. And so we're given an example of an inequality here. And in numbers, if we have an inequality, it has two sides, and you have to remember that because it has two sides, whatever you do to one side, if you do that same thing to the other side, then it's still the same value. It still represents the same thing, but in an equation. But in an inequality, what we're going to say is that it represents the same truth. So what I mean by that, so this is the same truth. And what I mean by that is that if we were to read this original inequality, -4 is less than 3, and we add 2 to both sides, we end up with our new inequality of -2 is less than 5. Now, it is true that -4 is less than 3, and adding 2 to both sides remains this inequality as true. And so that's what this is saying, is that if you add anything to both sides, as long as you're adding the same thing, then it still remains true. So for example, if I said something like Luz has $1,000, which is greater than the amount of money that Arlef has, which is $500, if I were to give to both of them $1,000 extra, Luz would now have $2,000, and then Arlef would now have $1,500, and it still remains true that Luz has more money than Arlef, or Luz's value is greater than Arlef's value. And so that is what this is saying, is adding anything to both sides is going to remain true for both. And you can write this example down here if you'd like. Now, in algebra form, is read as, if A is less than B, then A plus C is less than B plus C. So if A and B are two different numbers, then adding C to both of them, adding any number to both of them, remains true. The A plus C is still going to be B less than B plus C. And then here we've got the opposite. If A is greater than B, then A plus C is greater than B plus C. So what this is saying is that the sign in the middle, the comparison, doesn't change. It's still going to be less than, or it's still going to be greater than, depending on what you're adding. And this is going to make a lot more sense as we're practicing. And then the same goes for, and I'm just going to erase this, you don't have to erase this on your paper, but the same goes for the subtraction property of inequality. The subtraction property is the same thing as the addition property. You're just subtracting things now. So when you subtract the same number from each side of an inequality, the inequality remains true. So if I have negative 2 is less than 2, and that makes sense because a negative number is less than a positive number, and I subtract 3 from both sides, even though now that positive 2 has become a negative 1, the statement is still true. This comparison, negative 5, what is negative 2 plus negative 3? That negative 5 is less than the 2 plus negative 3, the negative 1. Because we added the same thing to both sides, so therefore the comparison is not going to change. Or in algebra terms, if A is less than B and A and B are different numbers, then A minus C, or subtracting C from A, is still going to be less than subtracting C from B, because it's the same numbers and you're taking the same thing away, so they're still going to be the same value. They're still going to have the same comparison. And then here's an important note, is that these properties are also true for less than or equal to, or greater than or equal to. So in an inequality, adding or subtracting the same thing from both sides does not change the comparison. So it does not change the symbol in the middle. It changes the numbers on both sides, but it does not change the symbol in the middle or the comparison symbol. So let's write that. So adding or subtracting any number from both sides of an equality does not, and I'm going to write that in a different color, does not change the symbol in the middle, the comparison symbol. So very important, because if we add something or subtract something from either side of an inequality, it does not change the symbol in the middle. The only thing that changes is the numbers, but the symbol is still true. Something will still be less than or greater than or equal to, or less than or equal to. The only thing that is changing is the numbers. And so this is going to actually bring us into solving inequalities. And just the same way that we solved equations, we're going to be using addition or subtraction to get the variable by itself. So if we scroll down and we do an example, we're going to do an example together, and we are being asked to solve x minus 5 as less than negative 3, and then we're being asked to graph the solution. So we've got a number line here that we can use to graph the solution for. So I need to solve x minus 5 is less than negative 3. What does it mean to solve an inequality? What that means is that I want to get this x by itself, just like I would do in an equation. I want to get the x by itself, and then I already drew out the symbol because the symbol is not going to change. Symbol is not going to change. The only things that are going to change are what's on both sides. So as you can see here, this x minus 5 is going to change to just an x. And then now we got to figure out what do we need to do to x minus 5 to change it to x? And what is going to happen to negative 3 when we do something to the left side? Because whatever we do to the left side, we have to do to the right side. So let's solve that out. So if this is x minus 5 is less than negative 3, I can get rid of this minus 5 by using the inverse operation. Now, that's a good question that you're probably asking yourself, is what is an inverse operation? So what is an inverse operation? I'll actually include the answer for that one in here. Is we can consider this to be the opposite, and I'm going to put that in quotes because that isn't really the technical term for it, but we can consider it to be the opposite operation, and you guys have heard me say that a couple of times. So we can consider the inverse operation to be the opposite operation. So if over here I have x minus 5, I'm going to use the inverse operation to get rid of that minus 5. I'm going to do plus 5. And then if I add 5 to the left side, I'm going to add 5 to the right side as well. Now, x minus 5 plus 5, that minus 5 and plus 5, they're going to cancel out to leave me with just the x that's already drawn here. And then over here on the right side, I've got negative 3 plus 5. Well, negative 3 plus 5 is going to bring me into the positives, and it's going to bring me 2 units into the positives. And I can actually show you this here. Negative 3 plus 5, 1, 2, 3, 4, 5, leaves me with a positive 2. And so I just solved that x is less than a positive 2. And x, I should really say this as x is all values less than positive 2. So this translates to x is all values less than positive 2. And so now it wants me to graph this information. So I'm going to go ahead and graph this information. Let's use purple because purple is a nice color. So I need to first determine whether I'm using an open or a closed circle at 2. Well, because there's no equal sign, I'm going to be using an open circle, which means that 2 itself is not part of the solution. Plugging in 2 for x does not give you a true inequality. 2 is not less than 2. 2 is equal to 2. So therefore, I'm going to use an open circle. And then x is all values that are less than 2, which is going to be in this left direction. The numbers go down as we go to the left. And so now I have graphed the solutions to this inequality. So first thing we did was we took this original inequality, took this original inequality, x minus 5 is less than negative 3, and we transformed it to x is less than 2. These are the same inequalities, but because we added 5 to both sides, it still has the same value and it's still true. It still has the same truth, but now we know all of the values that x can equal. So that means that plugging in, and this is really important, that means that plugging in any of these values in this left to the left of positive 2 into this x here will give me a true statement. And we can test that. Let's test that now. So let's choose any number. I'm going to choose negative 5. So I'm going to plug in negative 5 into x. I'm going to do that over here. So this is example 1. So I'm going to plug in negative 5. Negative 5 minus 5 is less than negative 3. And we're going to see if that's true. Well, negative 5 minus 5, that's negative 10. And negative 10 is indeed less than negative 3. So that is a true statement. And if I plug in any numbers to the right side of negative 2, anything on this side, you're going to see that we're going to get a false statement. So if I take a positive 5 and I do example 2, I'm going to do example 2 down here, and I do example 2, positive 5 minus 5, that's 0, is less than negative 3. 0 is less than negative 3. Is that a true statement? 0 is actually greater than negative 3. So that is a false statement. And so that kind of goes to show you that if you plug in any number to the left of 2, as we show on our graph, then you will get a true statement. Anything to the right will give you a false statement. Okay, so now you've got some on your own to solve. I've got 3 here for you. And so just a reminder, you're going to be getting the variables by themselves, and you're not going to change the symbol. So you're going to be adding or subtracting something to both sides, but the symbols, it's really important that you do not change them. So this should look something towards the end like y is greater than, and then you want to determine that number. And for number 2, you want to see b is less than or equal to, and determine that number. And then over here, you're going to keep that same greater than sign, and z is going to equal something. So you have to determine what's on the other end, and then make sure to also graph that information.